and you were trying to find out the numbers that went into 4. So 2 numbers that go into 4. I would say 2 and 2. What other ways can we factor this? Find the factoring primes to this. Well, we can say 4 is also 1 and 4. Yeah, well, that's the same way. So there's multiple ways. So as long as you can factor it down to its primes, now that's what you're looking for. These are prime numbers. Not that one. But these are prime numbers. That's what you're trying to do with this. This is the whole objective. Now when you're multiplying these numbers, we're not doing like 1.5 times 1.5. Trying to get down to prime numbers. Let's do 12. What goes into 12? 2 numbers can go into 12. 2 and 6. Also, what numbers? 2 numbers can go into 6. I would say 2 and 3. So no numbers can go into 3 except for 1 and 3. And no numbers can go into 2 except for 1 and 2. So these are the primes. And that's what we're looking for. 2, 2, 3. Now we can do 12 a different way. 1 and 12. We can do 12 doing 3 and 4. And you notice all these have the same primes. They all have 2 2s and a 3 in it, except for this one, but we don't count that one. That's just 1. 1 times anything is whatever it's multiplied. So we just ignore that. We're looking for anything greater than 1, that's a prime. So anything greater than 1 that's a prime is a 2. So each one has a 2, and a 3. No matter which way you go. So if you do it, break it up 2 to 6, 3 to 4, and you break down the 6, 2 and 3, 2 and 3. So you multiply these together, 2 times 2 times 3, you get 12. So 2 times 2, 4, 4 times 3, 12. There's multiple ways of breaking down this number. And these are called factoring trees, branches. They help you find the prime numbers of the bigger number. So 60. Let's see what we can break this up to. I would say 6 and 10. But what does 10 and 6 break into? 2 and 3? 2 and 5. Right? 5, you can't do anything except for 1 and 5. We don't want that. And that's a prime. 1 and 2, 1 and 3, 1 and 2. So these are going to be prime numbers right here. And that's what we're looking for. But you can do 60 another way. 60, you can break this up to 3 and 20. We know 3 is a prime, so that's good. We're looking for those. 20 you can break up in 10 and 2. 2 is good because it's a prime, but 10 is not. 10 you can break up a little further. 2 and 5. So here's your prime numbers. You see that these prime numbers are the same as these prime numbers. You have a 2 here, a 2 here, and you also have a 3 here, and a 5. This is the exact same thing as this. So no matter which way you do, which number you break it into, as long as you get whole numbers, you get the same primes. So as long as you do break this up by a whole number or an integer, you get the same primes. We're not going to break the 60 into 1.5 into whatever that is. We don't want decimals. So what else can we do 60 into? 60. 4 and 15. Yes. But 4, you can do 2 times 2 is 4. And also, 4 can be 1 times 4. So this is not a prime, but these are primes. 15, 3 and 5. So break down everything into primes. You see, 2, 2, 3, 5. 2, 2, 3, 5. It's the same thing. And so I just divided this by 4 and I got 15. And then I divided 15 to 3 and I got 5. Divided 60 by 3 and I got 20. 20 divided by 2 gave me 10. 10 divided by 2 gave me 5. So you can divide usually by a 2 or a 3 and you can break it down. As long as you're dividing these numbers and you're not getting some decimal, then you're going down the factoring chain. Usually what happens is the bigger the number you're factoring, the more primes you're going to get out of it, because it's just made up of a whole bunch of other numbers. So let's take 144. There's going to be a lot of ways you can factor this. Let's divide it by 2. You get 72. 2 is a prime. So we chose that number ourselves. Now, let's divide by 2 again. And you get 36. And that's prime, so we stopped that one. But we still got 36. What 2 numbers can you think of off the top of your head equals 36? 6 times 6. That's a good number. If you go 2, on this side you get 18, but you'd have to break that down 18 again. And this is a little way, it's a little faster. So 2 and 3, you get the same prime numbers. There's a 2 and there's a 3, there's a 3 and 2. So how many 2's we have? 1, 2, 3, 4. 1, 2, 3, 4. 2 3's. 3 and 3. Yeah? Okay. Now we can do 144 once again. This time, I know what 144. I know 2 numbers off the top of my head, 12 and 12. That makes it a lot easier if you know 2 numbers besides a lower prime number. These don't have to be primes as long as they come out as whole numbers, but you're trying to get to primes. So now you still got to break these up. So you don't always have to divide this by 2. You can find 2 numbers that you know that are not primes to break this up. But then these aren't primes, so that means you have to break those up. So let's go 4 and 3. 4 and 3. Well, we know 3 is a prime. 4 is not, because you can have multiple factorings out of that. It looks exactly the same as that. There's 2, 2, 2, 2, 3, and 3. And of course, 144, 1. And you can break that up. See, 1 doesn't really count because you still got to break it up into its primes, and we've already done this. So there's multiple ways to do bigger numbers, but be careful. Some bigger numbers are prime numbers. So if you're taking a number and you're trying to divide it by smaller primes like 2 and 3, 5 and 7, and you kept getting fractions or 1.6, decimals, then that's a prime number.